Okay, today we're going to look at the quadratic formula. So this is a formula that you do need to know, you need to memorize. This is the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. And we use this when we're solving a quadratic. So for example, if we have ax squared plus bx plus c equals 0, then we could use the following, the letters to solve for x. We use the quadratic formula. We can use it any time to solve a quadratic equation like we have here. But most specifically, we use it when we can't factor and we're just kind of stuck. So you can always resort to the quadratic formula if you can't figure out how to factor or what to factor, even if you can factor. Okay, so let's apply this quadratic formula. Here are some examples. The formula is up here in the right-hand corner, and again, this is x is equal to. So our a in this case is 2, the coefficient of x squared. Our b is 11, and our c is 15. So if we apply the quadratic formula, we'll have negative b, so negative 11, plus or minus the square root of 11 squared minus 4 times our a, which is 2, times 15, which is our c, all divided by 2 times 2. And this is equal to x. Okay, so when we simplify that, we have negative 11 plus or minus the square root of 121 minus 4 times 30, so minus 120 over 4. So we have negative 11 plus or minus the square root of 1 over 4, which is, the square root of 1 is 1, so plus or minus 1 over 4. So we've got two answers here. We've got x equals negative 11 plus 1 over 4, which is negative 10 over 4, or negative 10 over 4, or negative 5 over 2. So it's one answer, and our second answer is negative 11, and then notice the plus or minus, so negative 11 minus 1 over 4, which gives us negative 12 over 4, which gives us negative 3. So that's one solution. If you want to try the next two examples, so in this one, a is going to be equal to 5, b is equal to negative 3. So when you plug that in the formula, you'll have a positive 3 for your negative b, plus or minus the square root of negative 3 squared minus 4 times your a, which is 5, and then c is 8. Over 2 times a, which is 5. And you can simplify that to find your x. And also try the last one as well. And for the last one, in order to use the quadratic formula, it has to be equal to 0. So we have to add 25 to the other side first. So we have 4n squared minus 20n plus 25 is equal to 0. So in this case, our a is 4, b is negative 20, and c is positive 25. So take a minute, pause the video, work out those last two, and then I'll just show you the answers. So here are the answers for all of them, for the second one and the third one. So we got the first one. We've got two roots. Notice in the very first example there were two solutions. Okay, so in the first example we had negative 5 over 2 It should actually be negative 2.5. That should be negative. Okay, so in the first one, we got negative 2.5, we've got negative 3, we have two roots, we have two solutions. In the second one, we actually have no roots, because you can't find the square root of a negative. You'll get 9 minus 20 times 8, 160. 9 minus 160, you're going to get a negative number. And we can't take the square root of a negative number. So there's no solution. There's no solution for x, and it means there's no roots, or in other words, solutions for this quadratic equation. Number 3, you'll find there's actually one root, and that's because what you get under your square root should give you 0. So when we do that, we get a positive 20 for a negative b plus or minus the square root of negative 20 squared minus 4 times 4 times 25. So we've got, and this is all over 2 times 4. Okay, and notice under our square root, if we do negative 20 squared, we have 400. And then we have minus 4 times 4 times 25 also gives us 400. So 400 minus 400, that's going to give us a square root of 0, which is just 0. So we get 20 plus or minus, so x is equal to 20 plus or minus 0 over 8. Or in other words, just 20 over 8, because if we add 0 and subtract 0, we're still going to get 20. So 20 over 8, which reduces to 5 over 2. So there's one root, and if we add 0, we get 5 over 2. If we subtract 0, we get 5 over 2. So that one root is 5 over 2 and 5 over 2. You can say we have two solutions, but it's the same solution, or you can just say our one solution is 5 over 2, or 2.5. Okay, when dealing with the quadratic formula, the part underneath the square root is very, very important. So notice in the last example, and by the part under the square root, I mean this, b squared minus 4ac. So notice in the very first example, we had two solutions. And that happened because what was underneath the square root, the b squared minus 4ac, which is called the discriminant, was greater than 0. It was positive. So if the discriminant, b squared minus 4ac, is positive, we get two roots. Notice in the last example, that third one, we had our square root was equal to 0, and we only got one solution in the end, or two of the same solution. That happens when b squared minus 4ac, or the discriminant, is equal to 0. We get one solution, or one root. Root, solution, same thing. And then in the second one, we had 9 minus 160, and that gave us a negative number. And we can't take a square root of a negative. It's not possible to still get a real number. So when our discriminant is less than 0, or when our discriminant is negative, we have no solutions. We have no roots. X cannot be found. Okay, and that happens when the discriminant is negative. Okay, we won't actually be graphing in this unit, but just so you can visualize what's happening. When you graph these quadratic equations, you'll end up with a parabola. If you plug these into your calculator, you'll get a parabola, and in a couple units, we'll actually look at graphing parabolas. But just so you can picture, what it means when we're talking about one root, no roots, or two roots. This very first parabola on the left has two roots. It has two solutions. It touches the x-axis in two places. So two roots are two solutions, and we can see that because it crosses the x-axis at these 2 points. And so we know that the discriminant, b squared minus 4ac, the part underneath the square root in the quadratic formula, is greater than than 0 because we have 2 roots. This next one is an example of no roots. Notice the quadratic equation, the parabola never actually touches the x-axis. There's no roots. There's no solutions. And that's because the discriminant is equal to is negative. B squared minus 4ac is negative, is less than 0 when we have no solution. And then in this last one, notice we have just one root, or the quadratic function only touches the x-axis at one point. So our one root here happens to be when x equals 2. So there's one solution, or one root, happens to be when x equals 2. And that must be because b squared minus 4ac is equal to 0. We get one solution, or one root, when b squared minus 4ac, the discriminant, is equal to 0. So in the first one we have 2 roots. We have x equals -2. We have x equals 2. And that is because the discriminant is positive. In the second one, we have no roots because the discriminant is negative. And notice the quadratic never actually crosses or touches the x-axis. Okay, so continuing with that idea, if we want to show that a quadratic equation has no real solutions, we're basically showing that the discriminant, which is b squared minus 4ac, is less than 0. Because when that happens, we're taking the square root of a negative number, and we know that we can't do that. So we get no solutions. We can't find x. Okay, so we want to show that the discriminant actually is less than 0. It actually is negative. So we take negative b squared minus negative 3 squared, which is our b, minus 4 times our a in this case is 1. We have a coefficient of 1 with our x squared, and our c is 12. So we've got 9 minus 4 times 12, or 9 minus 48, which we know is definitely going to be a negative number. What is it? Negative 39. Okay, so because the discriminant is negative, we have no real solutions. For this equation. Okay, so again, we're going to use the discriminant, and we're going to state the nature of the solution. So we're going to say, is there one solution? Is there 2 solutions? Are there 0 solutions? And we should be able to talk about them. So the discriminant, b squared minus 4ac. Okay, so we're gonna take our b, which is 4 square roots of 2, squared minus 4, a is 1, and c is 8. So if we square 4 square roots of 2, we have to square the 4, and we have to square the square root of 2. So 4 squared, and the square root of 2 squared, minus 4 times 8. So we get 16 for 4 squared. If we square the square root of 2, we get 2, minus 32. 16 times 2 is 32. And we get 0. So when our discriminant is 0, we know that there is one solution. But there's one root. And you could also say this as two equal roots, because that one root is going to be the same twice. Okay, the next one, we want to use the discriminant to state the nature of this this equation, the solutions to this equation. So we use negative b minus 4ac. Okay, so negative 5, oh, sorry, b squared minus 4ac is our discriminant. So b squared is 5. 5 squared minus 4 times 6 times negative 4 is our c. So we've got 25 minus 16 times 6, or 24 times 4, 24 times the negative 4. That negative is going to turn into a positive. So we have 25 plus 4, 56. Right, 16, oh, 80, 96. Yeah. 25 plus 96, so we get something very positive. So 101, 121. Okay, so because our discriminant is positive, we know that there are going to be two solutions. And remember, the discriminant is always going to be underneath the square root in the quadratic formula. If we have negative b plus or minus the square root of b squared minus 4ac over 2a, the discriminant is beneath the square root. And what's special about the square root of 121? Well, we know that 121 is a perfect square. We know the square root of 121 is 11. So actually, not only are they going to be two solutions, but they're going to be two rational solutions. Because 121 gives us a perfect square when we take the square root of it. Anytime you don't have a perfect square underneath your square root, there'll be irrational solutions. So if you get a positive number and you don't get a perfect square, you know it's going to give you two irrational solutions. In this case, we have two rational solutions because the square root of 121 is a perfect square. Okay, so again, we're going to use the discriminant, and we're going to determine which of these have rational roots that can be found by factoring. So b squared minus 4ac is our discriminant. We'll use our b squared minus 4 times 2 times 1. So 36 minus 8, or what is that, 28? Okay, and that's what's going to go underneath the square root when we do the quadratic formula. We'll have the square root of 28. We'll have our negative b plus or minus our square root of 28 over 2a. Okay, but the thing is, the square root of 28 is not a perfect square root. 28 is not a perfect square. So because of that, our solutions are going to be irrational. We'll have two solutions, but they will be two irrational solutions because 28 is not a perfect square. Two irrational solutions. Okay. So because the roots are irrational, they cannot be found by factoring. So if you tried to factor this first equation, you would not be able to factor it with rational coefficients. The second one, if we use our discriminant b squared minus 4ac, we know that our b is negative 10 minus 4 times h times negative 3. So we have 100 minus, or plus negative negative, so we have 12 times 8. So we have 100 plus, we get 6, 8, 9, yeah. Okay, so we have 196. And maybe you did or didn't know, but 196 is a perfect square. The square root of 196 is 14. So because it's positive, we will have two solutions, but they will be two rational solutions, because the square root of 196 is a perfect square root. And again, we have two solutions because it's positive. They're rational because 196 is a perfect square. Okay, next. Okay, so just a review of the discriminant. I know I threw a lot of information at you, and I just want to make sure you understand what the discriminant is and what it can tell us. So what is the discriminant in the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac over 2a, and this is equal to our variable, which is generally x. The discriminant is what is underneath the square root in the quadratic formula. So this is the discriminant, b squared minus 4ac. How do we use it and what can it tell us? Well, we use it to determine the number of roots that a quadratic equation will have, or the number of solutions that a quadratic equation will have. And those solutions can range from 0, 1, or 2. Okay, so 2 equal roots, that vocabulary actually means one solution. 2 equal roots means the same root twice. So if you have one solution, your discriminant is equal to 0. Ascribe the roots means tell how many roots you have, how many solutions you have. And ideally, are they rational or irrational? No real roots. So that means that our discriminant, b squared minus 4ac, is negative. It's less than 0. If there are no real roots, it means we'll be taking the square root of a negative number, which we know we can't do. So when that happens, there is no solution to our quadratic equation. Rational roots. So that occurs when our discriminant is not only greater than 0, so it's positive, but it also gives us a perfect square. A positive perfect square. So that happened when we got 121, which we know is a perfect square. It happened when we got 196. any positive perfect square. 4 is a positive perfect square, 16, 9, 25, etc. An equation will have real roots anytime our discriminant is roots, meaning more than one root, so anytime our discriminant is positive. So when our discriminant is positive, it will have real roots, which means two solutions. And we'll have a unique solution to our quadratic equation. A unique solution meaning one solution when the discriminant is equal to 0. Unique meaning only one. And that one solution could be repeated twice, meaning two equal roots. So those actually mean the same thing. Two equal roots or have a unique solution means the same thing. It happens when the discriminant is equal to 0. Okay, last little thing. We should be able to use the quadratic formula even when, say, a quadratic equation isn't set up with a perfect ax squared plus bx plus c is equal to 0. So we can manipulate this and get one side equal to 0 before we apply the quadratic formula. So we can FOIL and we can simplify to get it equal to 0, so x squared plus x minus 2, we can minus 5 over equals 0, and we get x squared plus x minus 7 is equal to 0. And then from here, it's asking us to use the quadratic formula, so we'll do that. Notice we can't factor this easily, can we? There's nothing that multiplies to -7 that adds to +1. So we can use our negative b plus or minus the square root of b squared minus 4 times 1 times -7 over 2 times 1. And we get notice we have negative times negative, so we get a positive 28 over 2. Okay, so -1 plus or minus the square root of 29 over 2. So square root of 29 is a prime number. We can't take anything out of our square root. We can't simplify it, so we can leave our two solutions as this. So our one solution is -1 plus the square root of 29 over 2, and our second solution is -1 minus the square root of 29 over 2. And notice it gives us two irrational solutions because we have a surd involved, the square root of 29 in our solution. Okay, the second one, we've got, and make sure you FOIL that, so you've got x plus 1 times x plus 1, so you get 2x in the middle. And when we equate one side equal to 0, we have 2x squared plus 2x minus 2 equals 0. And we can use the quadratic formula to solve this. So -2 plus or minus the square root of b squared, which is 2 minus 4 times 2 times -2 over 2 times a, which is 2. Okay, so -2 plus or minus 4. Negative times a negative gives us plus. We have 8 times 2 is 16 over 4. So we have -2 plus or minus the square root of 20 over 4. The square root of 20, if we do a factor tree with 20 we know we've got a pair of 2's. So we can pull out our 2. And now we can factor 2 out of both terms in the top. So we've got a 2, -1, plus or minus 1, square root of 5. And this is all over 4. And now we can cancel a 2 out of both the 2 and the 4. So we have -1 plus or minus the square root of 5 over 2. And that's our final solution. We can't simplify the square root of 5 anymore. We know we're going to get 2 solutions. They're going to be 2 irrational solutions because the square root of 5 is a third. Last one. Oh dear, it's kind of small. Let's move it down here. Okay, very last example. We can multiply everything by x plus 2. Sorry, by the quantity x plus 2. It's hard to see there. We can do that as long as we multiply everything by it, and we want to do that because, so that we can cancel our denominator of x plus 2. So we'll have x times x plus 2. We'll have x plus 2 over x plus 2. And we'll have 4 times x plus 2. This is going to nicely cancel to give us 1. Be careful, it doesn't cancel to 0, it cancels to 1. And now we can distribute. We've got x squared plus 2x plus that 1 is equal to 4x plus 8. We can get everything on one side so that the other side is equal to 0. We'll minus 4x, so we'll have minus 2x, and we'll minus 8, so minus 7 is equal to 0. Okay, 2 numbers that multiply to -7, add to -2, don't exist. So we can apply the quadratic formula. We've got a -2, or a positive 2, plus or minus the square root of -2 squared minus 4. Our a is 1. C is -7, all over 2 times 1. Okay, so we get x is equal to x is equal to 2 plus or minus 4 plus 28, because we have a negative times a negative, over 2. So we've got x equals 2 plus or minus the square root of 32 over 2. If we think about 32, when we do our factor tree, we can pull out 2 sets of 2's, but we've still got a square root of 2. So we'll have x is 2 plus or minus okay, and then we can factor out a 2 from our numerator. So x is 2 times 1 plus or minus 2 square roots of 2. And that allows us to cancel a 2 from both. And we're just left with x is equal to 1 plus or minus 2 square roots of 2. And that's our solution. So again, we have 2 solutions. They're both irrational solutions because we have a third in our solution. Thanks, guys.